Hello, everyone. I've got the top of the hour, so I want to go ahead and welcome you all in to this month's edition of the NCAT reoccurring webinar that we call From Research to Implementation. It's always an exciting time for me because I love to hear the input of what we've been doing with different technologies and then also see who's really using this out in the real world. So we love doing that. Today's topic is the use of plastics in asphalt pavements. So this is an exciting thing. I get asked all the time out in the world, hey, I heard we can put plastics in our roads, and they want to hear about it and know what we can and can't do. And so it's always great for us to be in the know and on the forefront of what's going on. So today, we've got Nathan's gonna introduce us to the topic with what NCAT has done in the past, and we've got Dr. Fan Yen is going to be our NCAT presenter, and Dr. Bill Butler is going to be our guest presenter. So Nathan is an assistant director for the test track research here at NCAT. He's responsible for overseeing the test track research programs. In his prior role, he served as a lab engineer for about 8 years in the NCAT lab. He specializes in balanced mix design and friction research. He holds a bachelor's degree and a master's degree that he both got here at Auburn University, and he's licensed in the state of Alabama. Nathan is also the proud father of a recent kindergarten graduate. So,
Hi.
Dr. Fan Yen is the assistant director here and an associate research professor at NCAT. He holds his bachelor's degree in transportation from Southeast University in China, followed by his master's and PhD that he got down in the beautiful city of Byron, Texas at Texas A&M University. Dr. Yen's research focuses on sustainable pavements, includes balanced mix design, recycled asphalt materials, and incorporating the use of plastics into asphalt mixtures. He's co-led over $4.5 million worth of research over the last few years. He's licensed in Texas, and he can also do over 65 pull-ups in less than 20 minutes. We hope his presentation has a picture of Kyle. Dr. Bill Butler earned his bachelor's, master's, and PhD all from Penn State University. He's currently the Glenn Barton Chair of Flexible Pavement Technology and a professor for the Department of Civil and Environmental Engineering at University of Missouri, where he leads the Mizzou Asphalt Pavement Innovation Lab. He's also the founding director of the Missouri Center for Transportation Innovation. He is a leading expert in sustainability resilience of asphalt pavements, including the use of recycled plastics, ground tire rubber, and other additives in asphalt mixtures. So given all of that, I want to remind you, please stay muted during the presentations. We'll open up questions at the end. Please type them in the chat box for us. Given that, Nathan, please take it away.
Can you hear me, Travis?
Yes, sir.
All right, and feel free to go ahead and get your questions in, even while we're presenting, and if they're simple, we'll answer them in the chat. If it's kind of something we need to discuss, we'll answer them at the end. But that way, we can go ahead and queue them up. So if you have questions, go ahead and add them whenever you can. All right. So yeah, Travis already talked about this. I'm just going to introduce the topic for today, and then we'll talk a little bit about what NCAT has done, and then we'd love to hear kind of our industry support and what they're doing, or folks outside of the NCAT world. So that's why we have Dr. Bill Butler with us today. So NCAT's history when it comes to plastics and asphalt started back at the 2021 test track. Obviously in the work, leading up probably about 2020, as we were doing some of the preparatory work to get ready for that test track cycle. And then we had two test track sections, both a wet application method and a dry application method that were placed in 2021. The original goal was to have that be a single cycle test section to go from 2021 to 2024. But the sponsors of that elected to push an additional cycle to get to 20 million easels. So this is one of the ongoing test track sections currently on the track, leading up until the end of this cycle in 2027. After this work started, many other lab projects followed, some related to the test track, some elsewhere, looking at different plastic types. So recycled plastics, but also more engineered products. I'm not going to steal Van's thunder. I won't even try. He's much smarter than I am. and much more capable of speaking about some of these differences. But we did place 2 more plastic-based sections on the track in 2024. So actually, we had a big sponsor meeting yesterday, which is the reason why this meeting is on a Friday and not yesterday. And Fan was able to walk 800 feet of plastic modified asphalt sections because they were all back to back to back to back. So I'm just showing you some pictures from plant production and paving of those test track sections. We were able to use the high-tech feeding system, one of the newer devices that high-tech has developed, which is a little, the way he described it is a little more fine-tuned, has the ability to feed these plastic or rubber pellets at a finer rate, especially at the lower dosages. So for the 2 plastic sections, we actually added them right into the wrap collar of our Aztec double barrel plant, and then we paved them on the test track thick lift, 5.5 inches. So with that, I honestly, I'm gonna leave it over to Fan. He's much more capable of discussing some of the details. So Fan, we're gonna kick it to you.
Well, good morning, good afternoon, depending on where you are. We appreciate your attending today's webinar. As Travis and Nathan introduced the topic, we're gonna kind of like talk about using recycled plastics. For my section of today's webinar, I'm gonna kind of like share some of the lessons that we have learned from the NCAT test track so far, and also NCHRP projects that we completed last year. So obviously, like there has been lots more work that has been done at NCAT, but for the interest of time today, I'm going to focus on kind of like the most important finding from these efforts, and hopefully that's something that will allow you to take home to tie back to the kind of like the focus of the webinar series is on implementation. With that being said, I'm going to start with what we have on the test track, kind of like follow what Nathan introduced earlier. In the current cycle, we have 2 new test sections using the plastic engineered additives. Those are more like virgin materials. But in the previous cycle that we started from, like using we did 2 test sections using recycled plastic, and that's what I'm going to focus on in this part of the presentation. Obviously, I want to give a shout out to our sponsors of the additive group experiment. The 2 sections that include recycled plastic are the ones on the south tangent of the track, S5 and S6. And I'll give you more information about those 2 sections. Before we dive into kind of like the recycled plastic discussion, just want to kind of like, remind everyone or set the stage, if you will, on what we try to accomplish from this, great experiment that we have been doing on the NCAT test track. The whole additive group experiment aims to comprehensively evaluate the performance impact of multiple mixed additives at the same time. One thing we are not going to talk about today is like some additional additives besides recycled plastic, including ground tire rubber and also fiber. But for today's discussion, we're going to focus on recycled plastics. What we really like to establish at the end of the experiment is a process that can be used by state highway agencies or our industry to evaluate future additive without having to build a test section. So that's really kind of like the end product, if you will, we like to bring to the table on the implementation side. A little bit of information on the pavement structure design of the test section we have on the NCAT test track. We have 6 test sections, including a control that use SBS polymer modifying binder. For all the other sections, they all have shared the same pavement structure so that whatever difference we see in their field performance can be attributed to the mix quality. As you can see on the slide, the pavement structure includes the 5.5 inch asphalt over 6 inch aggregate base, and then on top of our test track subgrade. One very unique thing that we did as part of this experiment is that we placed the 5.5 inch asphalt in single lift. I know it's not very kind of like a traditional way of doing pavement construction, especially for flexible pavement. The reason we did that is try to eliminate any potential confounding impact from kind of like debonding issues between layers. So this is really kind of like a unique cool thing that we have the opportunity to do as a test track because it is a well-controlled environment. So it gives us the opportunity to kind of like play with different approaches to make sure like we can truly maximize the benefits or the research that we're doing for our community. And then for the experiment we have at the NCAT test track, the focus of this experiment is bottom-up fatigue cracking. We also have a companion experiment up in Minnesota with our, kind of like based on our collaboration with the Main Road. For their experiment, more focused on reflective cracking and thermal cracking. But for what we have on the track, bottom-up fatigue cracking is kind of like what we are anticipating those sections to kind of like to be evaluated against. Some quick information about the recycled plastics. I think one thing I learned over the years by doing research or kind of like implementation on recycled plastic is that, this material is so much more complicated than just saying like, hey, it's just recycled plastic. I'm sure like many of you have experience of trying to explain to other people not in our industry saying like, hey, asphalt binder is not just asphalt binder, right? There are just so many different variable that can contribute to the different properties of how this material perform. I mean, this is so much true, the same for like recycled plastics. The specific material that we used in the two plastic sections from the 2021 additive group experiment are post-consumer recycled linear low density polyethylene. And also like I put some basic information for those who knows, quite a bit about the plastic. So hopefully that will give you a pretty good idea of the material that we used. The way we introduce the material into our asphalt mixture include like a two method. One is what we call like the wet process. Basically for this process, we are adding these pellets, as you can see on this screen, into the asphalt binder. Because it goes into the liquid phase, that's why like we refer to that as wet process. For the other method we evaluate as part of this experiment was the dry process. So instead of adding this material, this plastic pellet into the liquid phase, we decided to add that into the aggregate phase or the solid phase, and therefore the dry process. And then those are the two most common approaches of adding plastics. There are pros and cons about each method, but we will be happy to have those discussions at the end of the webinar if you guys are interested. One thing I would like to clarify is that even though we call like the wet process of adding recycled plastics, the formulation that we use in the test section of the test track is really not just about the plastic. And there is good reasons for doing that. For those of you who knows, asphalt binder and the plastic, those two materials do not like each other. Okay, I mean we can use high temperature, we can use high shear, low shear to force them together. But once you stop that agitation or stop the temperature history there, those materials are going to separate. So with that being said, the separation issue is a big challenge for the wet process. And in order to address that issue, at least in this specific formulation, we have to do some formulation work to make sure like those two materials like each other, if you will. And then the approach we took was working with Dow Chemicals to introduce a terpolymer into the system so that, almost like the terpolymer can hold hand, with one side to the asphalt binder and the other side on the recycled plastic, saying like, hey guys, let's work together to make it work. And also because of the terpolymer introduced, we are also adding PPA just to speed up the chemical reaction between the terpolymer and asphalt binder. So if you look at, the information here, now you understand why I said, even though we call it, wet plastic, it's really not just plastic. It's a hybrid polymer system that includes the plastic as part of the picture. You may wonder, like, how did we determine the dosage? We did quite a bit of work up front before we do production, just to make sure, like, we are achieving the engineered property of the binder that we are looking for. In short, what we did was try to match the percent recovery of the SBS binder and also at the same time maintain good storage stability. So we definitely don't want those materials to separate in the tank. That can be a nightmare from the production operation perspective. And then all the other, mixture components were kept the same. So the only difference from the SBS control mix was like we switched the binder from the SBS binder to this hybrid polymer system using plastics. With that being said, this material or this mix allow us to look into the potential of using plastic along with some other, terpolymer system to behave as a potential SBS alternative. For the dry process mix, it's a little bit different approach. After discussing with our sponsors, there was interest in looking into adding recycled plastic using the drop-in approach. So basically, we did not do any other modifications from the control mix. All we did was add 0.5% of the linear low density polyethylene pellets that I showed you on the previous slide into the mixture during production, and to see what happened on the mixture performance. So with that being said, if we see any difference, we can attribute that difference to adding the addition of this 0.5% linear low density polyethylene. If you look at the dosage here between the two processes, like dry process and wet process, the dosage for the dry process of the recycled plastic is almost like 10 times higher than wet process. But one thing I want to, make you guys aware is that it's not like the more we put in, the better. I think at the end of the day, we want to look at the performance, right? Obviously, like this is kind of like goes back to what we want to do for our industry, is to make sure like our payment gonna last long, at the same time can offer sustainability benefits. So those are the differences between the wet process and the dry process. Nathan showed a quick picture earlier in his PowerPoint about kind of like the feeder system that we use to add the dry plastic pellets during production. It went really well. We fed into the plant at the wrap inlay, and then we verified the dosage. It was very accurate compared to what we were targeting. So we were very pleased with that. For wet plastic, because we are talking about a modified binder system, what we did was to working with our binder supplier to do a terminal blending of that system. So once again, it's not just recycled plastic adding into the binder. We introduce the terpolymer, PPA, try to stabilize and then achieve good elasticity from the percent recovery perspective as compared to the SBS. So overall, like, the production went really well. Definitely want to shout out to our binder supplier and East Alabama Paving to work with us to make it happen. During production, we sampled quite a bit of mix for both SBS control mix, wet plastic and dry plastic mixes, and our lab engineers have been very busy doing the lab characterization of those materials. For the interest of time today, I'm not going to show you kind of like, the detailed test result, but I'm hoping that the summary table give you a quick overview of the major finding that we have seen so far. So what I'm showing here is a comparison between the wet or dry plastic mixes over the SBS control, okay? And I grouped them into kind of like three tiers or three categories, if you will, with the first one being stiffness, second one being rutting resistant, and then the last one being cracking resistance. So if you look at the wet plastic mix, pretty much we were able to match, the engineering properties of the SBS, which is really not very surprising to us because, as I mentioned, we did our homework up front to really engineer the binder formulation to make sure it's going to perform. So this is a very important finding, is that it's not something that we should expect to just drop in recycled plastic and hoping that it's going to work. But we should, as engineers, we really need to engineer the formulation for wet process. And, the result definitely is showing the promising expectation that we had. The only difference we saw is that when we look at the plant-produced mixes, the wet plastic mix did not perform as well as the SBS control mix when we look at ideal CT or AMPT cyclic fatigue or bending beam. That was a little bit different from what we saw in the lab results, and I think that could be something related to the production variability that caused a little bit of variation. But overall, like, we have been very pleased with the wet process formulation that we came up with by working with Dow Chemicals. If you look at the right side of the table, focus on the dry plastics, what we saw was kind of like a very significant stiffening impact from dropping in those plastic pellets. We saw higher stiffness, we saw like a better rutting resistance, but at the same time, on the cracking side, we saw a detrimental impact on that. So it's almost like with that stiffening impact, the material is more brittle and does not have good relaxation properties, and therefore it is going to sacrifice the cracking or the durability perspective of the mixture performance. So this goes back to what I mentioned earlier, is that in order to make it work, based on what we have learned so far, just dropping in the approach, dropping in those additives is not going to be a good engineer approach. Instead, we should really engineer the formulation for wet process and engineer the mix design to make it work. So that's kind of like the a quick summary of what we have learned so far from the mix quality perspective. Now you may wonder, like, hey, how do those sections perform at this point? Nathan mentioned earlier that the original plan was to go with one research cycle with 10-minute easels, but we discussing with the sponsor, we decided to push for another cycle. What I'm showing here is the field performance up to this point. We are a little bit around like 12-minute easels, but the data I'm showing here was from like 11-minute easels. Rutting was not a concern at all. We did not see any rutting issues or potential rutting concerns for any of these sections, which is very as expected because our lab performance data indicate that way. But if you look at the cracking side, this is where we saw some very interesting findings. For the wet plastic and SBS control section, they have been performed like perfectly with no cracking. But when we look at the dry plastic, the section, as you can see here, started to show some cracking initiation somewhere between like 7 to 8-minute easels. And obviously, like the cracking has started propagating over time. At this point, we are 5.1% cracking in terms of length area on the test track. And it will be interesting to see like how long it's going to take for the cracking to develop and then got to the point where we feel like we have to take it out and call it the failure of the experiment. So overall, like this field performance, even though it's still early, shows a very consistent trend as compared to what we saw in the lab. So that gives us, definitely confident into, some of the BMD or fundamental characterization that we have been doing in the lab. In terms of friction, I know there were a few years ago, there were some interest in whether or not adding plastic can affect the friction, the surface friction characteristic of asphalt mixtures. Based on our data, it does not appear to be the case because we saw very similar friction on all three sections. Now I'm going to switch gear to talk a little bit about the NCHRP projects. And like I said, for the interest of time, I mean, we have learned quite a bit from the NCHRP work, but for today's presentation, I'm only going to highlight the most important findings. Just want to make sure we're all on the same page. The objective of this NCHRP work was to look into the impact of post-consumer recycled plastic on the performance properties of asphalt mixtures using the dry process. Okay, we're not talking about adding the material into the binder, but instead adding into the mixture at the solid phase. There are some other like secondary objectives, but those were really not the focus of today's discussion. In order to achieve those objectives, we set up a very comprehensive and systematic research plan to tackle those challenges. Like I said, what I'm going to share you today is kind of like the major findings, and hopefully that's something that you're going to take away from today's webinar. I mentioned earlier that recycled plastic is very complicated. What I'm showing here is a picture of the 12 different plastic samples that we included in the experiment. We did a very comprehensive evaluation into their property, and what we learned is that these materials are very different, in terms of their physical, thermal, and chemical properties. So just calling like a recycled plastic is a way, oversimplified of that material. Okay, we really need to be very specific about, the property that we're looking at, because that property difference will affect the mixture performance. That's something that I'll give you some more information later. Another major finding from this characterization perspective is that the majority of the plastics samples have very limited solubility in traditional asphalt solvent. So if you are dealing with using the dry process of adding these pellets into the mixture and hoping that you can do solvent extraction to look into the binder properties, you may want to think twice on that, because the solubility challenge can make your result or make your extracted binder may not be the same material as what you got in the mixture phase. You can still do the testing, get some result, but it may not be as accurate or as precise as you would hoped from the mixture level. Another major important finding we got is like a couple of the samples that we tested, we were surprised that they have some potential health and safety concerns, because when we look into the GCMS analysis, they have high volatile organic content. And also one of the samples even have the presence of benzene. That definitely something that we don't want to work with, not only in the lab, but also at the plant. So just, be mindful about that. Depending on where those materials come from, they could have these issues, and that's definitely something that need to be addressed moving forward. In terms of impact on mixture performance, we saw pretty much the same trend as what we have learned from the test track research. We saw the stiffening impact by looking at the stiffness or rutting resistance that can be beneficial for those who are struggling with rutting. But we saw like a detrimental side on the workability and the fatigue cracking resistance. And the other property we look at from the very comprehensive lab testing we did, they really did not have much significant impacts. One more thing I want to mention here is that, I mentioned earlier that recycled plastic are very different. And what we have found very interestingly is that the recycled plastic with a higher melt flow index, and those are the ones that, relatively speaking, have lower molecular weight or molecular structure, are the ones that have more significant stiffening impact. So it goes back to what I said a couple of times. It's like, it's not just recycled plastic, the type and the property of the recycled plastic really matter. The other thing that I want to share really quick is the QC testing of the plastics. One thing that has been identified as a knowledge gap is, the QC testing of the plastic. How do we know like the material we are using during production is a material that we were told, from the manufacturer? There are really two ways that we recommended from this research. One is a melt flow index. This is a well-established methodology that in the plastic industry that give you a relatively flow properties of the material that can tie indirectly to the type of material that are in those recycled plastics. The other thing that we had very success in this NCHRP project was using a near-infrared spectrometer. It was very easy to use. Pretty much it's kind of like a point and scan operation. You point the device into the material and you scan, the spectral, and then compare the results against, a database that has been established. And then that will give you, the major composition of the material in this recycled plastic. Based on our exploratory, testing, we found a very good match between the near infrared and FTIR. So that can be a very handy tool for those who like to verify the composition or the type of material before putting into, the plant for, production and construction. At the end of the NCHRP project, we put together a guide document with lots of good information that we hope that will serve as, some guidelines for those who are interested in playing with recycled plastic in asphalt mixtures. And this will be published as a part of the NCHRP, final report that's going to be available later this year. So stay tuned for that one. With that, that's all I got. I always like to show a picture with me visiting Hawaii, seeing the first plastic in asphalt road when I was there. And also Travis mentioned I got, a 3.5 months old at home. So that's him. So with that, I'm going to hand it over to Dr. Bill Butler.
All right. I think Travis might have froze here. Are you back, Travis?
Yeah, I can hear you.
Okay. Did you already do the introductions? Can I just let her rip?
Oh, yeah, absolutely. We're ready for you to just share your screen and go.
All right. I'll do so. Sorry about the reboot at the beginning. Glad to be with everybody, ladies and gentlemen. Hope everybody's having a good morning or afternoon if you're in a different time zone. Yeah, thanks. Great presentation, Fan. I'll try to just kind of build on some of the concepts that you presented with the Missouri experience. So our work started when one of our alumni, Jim Fitterling, who's the CEO of Dow and Dow DuPont, he comes by Mizzou all the time. He came by and he said, "Hey, we're working on the Alliance to End Plastic Waste. Do you think you can put plastic in asphalt?" This was years ago. So we started doing literature review and work. And next thing you know, we've got roads built all over Missouri. So this is what the presentation is all about, sort of this 6-year journey with playing with plastics, and especially waste plastics post-consumer in asphalt. So there's a lot of plastic in the environment. And I'm not going to say that just because we innovate with plastic and asphalt, somehow it's going to disappear from the oceans and land. But if we have a circular solution where we motivate people to actually recycle, or they think that if they recycle, it actually gets used for something, that's a step in the right direction. You can pay for waste plastic if you have good end uses, which may mean people will scour the environment to pull these out of the environment and use them for a good circular engineering use. So a lot of statistics here. I'll share these slides, but plastics can last forever, hundreds and hundreds of years in the environment, depends what they are. So this is certainly something, if our industry can help, let's do it. But we don't want to be a linear landfill, put yet another recycled material in asphalt. Everybody asks us to put everything in there, but I think because this is a polymer, it's pretty appealing to try to do that. We're not the first. If you look at India and just places all over Asia, there is a history of putting plastic in roads. We did a literature review and we tried to replicate what was being done in India, where they said that the waste plastics would melt and essentially cover the aggregates completely, like cap off the voids. And that's not how it worked. When we put it plastic in a bucket, mixed it with asphalt, it was a different process. So we started from scratch when we looked at what plastics to use and how to incorporate them in the lab in the field. But it was nice to know that it had been attempted successfully other places in the world. Why would we try to put some of these waste plastics in roads? It's just the tonnage, that's the appeal, that we do, hundreds of millions of tons of asphalt every year. It's billions of pounds. And so, if you look at the kind of the amount of plastics versus the amount of roads, there's maybe 30 million tons of plastics that are available for recycling every year, probably 15 million polyethylenes. And when you start to look at those poundages and the percentages we put in asphalt, pretty good chance to take a chunk out of that that amount of material. It's not inconceivable to think that we could take about 10% or 20% of the polyethylenes, especially the ones that nobody else wants, and use those in roads. Might be 20 years from now, but we'll see. So which plastics? Let's not do PVC. Chlorine, heat it up, bad. It's hard, it's brittle. Let somebody else try to use that. Polystyrenes, just chemically, we don't want to use those, and for worker safety reasons. PET, a lot of other people recycle those. That's great. They'll pay for those. We may not be able to afford it because we put asphalt down at pennies per pound. If it's dollars per ton, it's pennies per pound. And so that rules out when you get in a competitive recycling marketplace. But especially films, hard to shred, hard to reuse. Polyethylene films, they end up with food waste. They end up with multifunctional layers of different polyethylenes and even foils. Think of your potato bag chip, might have a little bit of foil material in there. And so, we can take the plastics that other people don't want to use, and that's where we get the lower price points for our recycled post-consumer polyethylenes. And, if you're not really familiar with asphalt paving or polymer modified asphalts, why would you even want to put polymers in asphalts? It's been shown for the last 3 decades to extend pavement life. It can maybe mitigate moisture damage. It can increase cracking resistance, rutting resistance at the same time, balance your mix design. So there's lots of reasons to engineer polymers into asphalt. And we generally use virgin polymers, but this is an opportunity to replace some of that or all of it with recycled polymers in appropriate applications. We did a demonstration on Stadium Boulevard after a couple of years of lab work showing that it was both performance ready and environmentally safe to use. I'm not going to get into the environmental part here, but we have looked at microparticle release studies and kind of vetted that out before we went to the road. And so just south of campus here near our softball and football stadiums, we have a connector road that goes to US 63, Stadium Boulevard. And we put a rubber section in the bottom left with engineered crumb rubber, which we have a lot more experience with, probably 20 years of research and practice with that. We know it works. And then we tried 3 different plastic sections. So we did 0.5 and 0.25 PE by weight of mix, and Dow Chemical helped us identify a supplier in Texas. In Houston, it was Avangard, and I think that same material has been used up in Min Road and NCAT as well. So we have 3 different places where this material has been used. I think we were the first to use it in a dry process in the US. I think Dow had a wet process project and then asked us to look at the dry process. So these are the first LLDPE pellets that we use. You can tell it's an extruded product that's chopped up. So you basically think of it as melting things like shopping bags, Walmart bags, and other wraps. Amazon, for instance, when they ship things in cardboard boxes, they first wrap pallets, and so that those pallet wrapping sheets are used in mass, and every community probably has lots and lots of cut off plastics or bags that are used for various things. This is what it looks like in a 1,000 pound or a half a ton distribution, where you have a plastic bag, which, by the way, you could recycle later back into the pellets, sitting in cardboard, sitting in a feeder system. I'll show you a little bit more about the feeder systems in a minute. On the stadium boulevard, you know, like all demonstrations, you ask where you can do it, and they're like, hey, we have this horrible pavement that you can use to test, and this was one of them. It was an old jointed concrete pavement. You can see how roughed up the joints look, spalled. It was milled down, and they're just trying to get like 5 years of life before they reconstruct this. We're already in year 4, and we're doing good. Probably do better than that, but just an inch and a half of resurfacing on top of concrete. So that's what we were given, and it's a great reflective cracking making pavement, as are most concrete pavements. They just sit there and shear and open up and close up with temperature, and they shear with traffic. So we do have a few reflective cracks, but the reflective cracking rates are sort of normal. And so, and we're doing better than the control section, which doesn't have recycled plastics. So, you know, it made a nice thin surface treatment for a little bit of a concrete life extension in this case. No ruts. Yeah, it's performing well. So MoDOT gave us a license to do a project on an interstate. And so here I just presented this at the NCAT sponsor meeting. So a little bit of those slides. So south of St. Louis, and actually closer to Memphis in the Boot Heel, near the Mississippi River, you have this spur of I-55 near Hayti and Caruthersville, where we built our 9 test sections. That was our original layout, but I've got a slide that shows the final layout. And so you can see we have control. Most of our sections are on the eastbound. If you ride back on the westbound, that's all control sections. The passing lanes are all control sections. And we looked at things like SMA versus dense graded for high traffic. We looked at SBS polymer versus PPA modification, polyphosphoric acid, to get a stiff massacre graded binder, versus recycled plastic and recycled rubber. So we also looked at scrap tires here as well. Some pictures of what we tested. We had used the LLDP from Avangard before, so we went to a lower cost product. They think this is about 1/3 of the cost. So really nice to get a product that you can actually afford in the mixed low density polyethylene. So you can see some of these pellets were blue, gray, brownish. It's hard to see the blue ones here, but they were there. From another partner, Driven Plastics out of Pueblo. They have a shredded plastic. They have all sorts of different shreds and grades. We chose the middle of the road product, which was their mixed density polyethylene shred. And then, of course, this 30 mesh engineered crumb rubber product that we're very familiar with in Missouri. We have a spec for that and similar dry process rubber. Those were all used. And then by the time you looked at SMA versus dense graded versus control and PPA, SBS, that's how we came up with the 9 sections. The dense graded gradations were your typical below the restricted zone, below the max density line here at the critical control sieve type blends. And then those were 12.5 nominal max. And we also had a 12.5 nominal max SMA with that characteristic gap gradation. These had anti-strip and fibers in them. We went with 30% wrap, yielding 25.5% asphalt binder replacement. The control section was what the contractor already was doing and wanted to do. And the contractor was wanting to use less wrap, I think 20% wrap. So the control section was actually, we didn't modify it. This was all about a joint special provision. It said you'd have to participate, you know, with a university experiment, but you had to be the low bidder and come up with a partnership. The university designed 8 of the mixes, and then we used the control mix, and then the contractor had to build all of 9 of the mixes for about a half a mile, and that was Delta Companies are the ones that won that contract and did a great job on the research and production. You'll see in my slides the details about the plastic amounts and, you know, what section is what. It'll take me a while to go through all that. MoDOT, this was years ago, a few years ago, when they were looking at minimum cracking test or CT index scoring, and they wanted to elevate it. So they had the contractor or us work on a couple of higher CT scores, like 80 and above, as opposed to the lower requirement for dense graded. Now, for SMA, they already had 125 minimum CT index. And, you know, as that rolls out, those numbers are clicking up. So we had sort of dense graded standard CT requirement, dense graded elevated CT requirement, and then over here, the SMAs with a 160 score minimum. And this was a 15,000 pass location, but we sort of did our designs with a 25 or 20,000 rather pass Hamburg. So more details about the mixes. We kind of swapped the order of the mixes because we were able to hit the elevated 80 minimum CT index with one of the modified mixes. So we kind of move that down in the list, and then the control mix was made with plastic. So we got another plastic mix out of that, and you can see kind of the anti-strip and fiber dosages. The somebody had asked in the chat a second ago, like, how much plastic do you put in? We generally target, all things being equal, about 0.5% plastic by weight of the mix. And so for every 5% asphalt content, if you put 0.5% plastic, it's about 10% plastic by weight of the binder. But by weight of the mix, it's about 0.5%. And that's the range there. The rubber goes in about the same. The ECR goes in at about 10% by weight of the binder, which is about 0.5% by weight of the mix. It's not exact because the SMAs are actually more like 6.5% asphalt content mixes. And so you can do the math there. Yeah, there's the volumetrics. You can see the VMAs for the SMAs are up in that 17 range, and the dense gradeds are more in the 14 range. And we had a little bit of a dust problem on the SMA control. It had kind of a lower design dust, and then the dust feeder was given fits during the project. So that parts of that had to be redone, but it's just things that happen during construction. We use some of our university technology, our Tiger Eye engineering. It's a vision system that does machine learning and does PCI scoring and identifies every crack by its type, extent, severity. And we did that on the concrete before, and then the asphalt afterwards. You can see evidence of Dalbar retrofit here. So they've been kind of wrestling with this concrete pavement for a while. Let's see. In terms of the plant, you know, we had to have a 2-feeder system for convenience, so we could do 9 test sections in like 2 days. And so we wanted to be able to switch from feeder to feeder so that we could load the feeder while we were, you know, and empty out a feeder while we were starting the next tech section. Also, we were using fibers in the SMA, and so we were able to blow fibers and plastics at the same time, or fibers and rubber at the same time. So not too hard to retrofit the plant to do that. And then you can see we're not feeding these additives in the wrap collar, which you could. This particular one had the asphalt coming in. It hits a deflector plate. It creates a fan of asphalt. And then you can inject the additives kind of hitting into that fan of asphalt so that it gets kind of incorporated in the asphalt, and then it tumbles through the last part of the drum. So that's a good way we find to do that. You don't want materials ending up in the dust collection system any more than they have to. So firing the dry additives right into the asphalt is an effective strategy. You can see the high-tech feeder that we use. High-tech is the name of the company, but it's also a high-tech device. It has a load side, and then it has a weigh side that's on load cells. And then you can see the tubes. They're like, I don't know, 4 or 6 inch diameter tubes that you can use to pneumatically inject or blow the granular feed into the asphalt plant. You can see a video of the driven plastics shred product being mixed up in the hopper. That is on the feed side, and then it goes through to the weigh side. And then you can see the Avangard pellets. You can see these ones. You can see the blue pellets now. So a mix of colors tells you that's a mix of plastics that are going in there. You can see the super sacks. They're 1-ton sacks. And in this case, we had super sacks for both the plastics and the rubber. So this is kind of a good way to deliver it. If you're doing a big project, you can bring it in on a truck that literally just dumps out of the bottom, or you can just kind of pull this material out of a delivery truck. And there's other feeder systems that allow you to go like truck by truck rather than bag by bag. So there's lots of innovation in this space. You can see we have the 2 feeders here. And Yeah, paving is kind of just business as normal. Great if you can use a shuttle buggy, obviously, to reduce thermal and material segregation. Always great practice, but kind of the temperatures of production and the materials you use, the paving train is essentially the same for the rubber and the plastic. So you can see breakdown, intermediate rollers there on the Interstate I-55 eastbound. It looks like asphalt while you're making it in the lab and in the field. You know, you can smell the rubber a little bit more than you can't really smell the plastic, but it's otherwise just kind of business as usual. If you want to come visit, we can take you out there. There's signage for all the 9 sections so you can see what's going on where. And after a couple 2.5 winters, you know, 2.5 years, couple winters, you can see some low severity reflective cracks. This was a 2-inch overlay, but only kind of less than 50% of the reflective cracks are at low severity. And then there's a lot of sites where the reflective cracks have not come through yet. Here's that bleeding in that control section where we had kind of low fines. And so we're going to keep an eye on that. But we have multiple control sections on this. And so we can compare kind of like a multi-control. This is an example of a mixed polyethylene showing one of the reflective cracks. Again, low severity. We'll keep tracking the type, extent, severity of all the distresses. But when you look at the pavement condition index and the international roughness index, these pavements are looking great still. I've got a slide on that in just a second. Here's you know, we go out with a mobile lab to keep it easy for contractors. So if you want to partner with us to do this, we'll help you with the mixed designs and the plant sampling. We can get out to the field and do that. As far as like cracking and rutting scores, cracking on the left, rutting on the right, we did both the design, which are the blue bars, lab mixed, lab compacted, the non-reheats were the plant mixed, and then sampling right out of the trucks, keep it hot, put it right into the gyratory, plant mixed, plant compacted, and then the reheats, because sometimes those are used for QA. And so we want to see where those numbers are going. Usually it gets more brittle in the CT and you might get a little more stiffness bump in the Hamburg with the reheats. You get quite a bit. So you can see kind of how those numbers look. The red lines indicate the thresholds. You can see the elevated BMD for the dense gradeds that we selected, and then the SMA being higher. And you can see the designs were either kind of like the control was towing the line, but a lot of the plastics and rubbers and SMAs were, you know, exceeding the crack requirements even during production, even some of the reheats. We have different criteria for the reheat, so you'd have like a second bar or second line that would be lower. I didn't show that, but on the Hamburgs, you know, stiff, like I think we heard before from fans, stiffness is not your problem with plastic mixes. The SMA control is the one that was giving us a little bit of trouble with the low dust, and you could see it in the performance test results on the Hamburg. And then as far as like international roughness index, you like to see asphalt, you can hit 40s and 50s after construction. Sorry, concrete industry, you can't do it. We can. And then those have stayed pretty good. We actually, because of the seasonal adjustment and roughness with the concrete pavement kind of doing this, we actually saw a little bit of decrease in IRI the second time we went out, but statistically similar and low. And then the PCIs are all between 90, 95, and 100 still. So really reflective cracking is the only distress except for that small section of bleeding. And to wrap things up and leave time for QC questions and answers, I should say QA. We're doing a little bit of modeling of reflective cracking. We're using an in-house code, comparing it to Abacus. For the first time, we'll look at crack raveling and severity. So we'll do some micromechanical modeling and kind of look at crack type, extent, severity, spalling with a model so we can make a simulative environment. And then I have 2 new slides. These I threw in at the last second. It's really the fans' question of like, okay, if you just throw the plastic in there dry, the rutting is mitigated, not the cracking. So we have an NSF grant where we're kind of addressing this idea that you know, everyone wants longer lasting roads. They cost less, and heck, even some states care about sustainability, but brittleness is an issue. And so last slide, we've got this Tiger Plast material that we're developing, and we're using a second sustainable product, just local bio resins, could be soybean or just using local materials. And we react those with plastics to create a much softer, balanced, mixed design product, kind of what contractors want. So it's like, don't just give me another stiff recycled ingredient. And so this is meant to be like a BMD sustainable additive. And so we'll be doing demonstrations. We have a partnership with an organic dairy in the area. We're taking all of their plastics coming out of their manufacturing plant, and we'll be putting it in the local roads in the next year or two. So had a great visit down to NCAT earlier this week. There's me and Buzz kind of in the front row looking at that Auburn game where they destroyed the opponent 19-1. So appreciate them inviting me down to speak earlier this week. Back to you, Mr. Moderator.
Great. Yeah, Bill, we loved having you. I know I learned a lot from hearing you talk. So I'm going to summarize our two presenters' content with just some basic recommendations, and I'd really love to get to some of these Q&A questions. Both presenters really made the point, not all recycled plastics are the same. There's a lot of problems with the drop-in approach of kind of just treating all plastics like they're the same. Some of these more engineered binder and mix engineered products and looking at binder testing and mix properties are important to make sure that we're actually getting good performance. Yeah, the drop-in approach, it's kind of fraught with problems. There's really no guarantee of success. There almost is a guarantee that you will stiffen up the mix. We definitely want to avoid plastics with potential health and safety concerns, but also some usability concerns. Bill talked about difference in types of plastics and difficulty in shredding and getting the right particle size for melting purposes and things like that. So pay close attention to that, but obviously health and safety is a big deal. And there's actually been some really good questions in the chat that I'll kick to Bill in just a moment. I loved, Bill, I really appreciated you bringing this up. That melted plastic does not coat the aggregate and prevent absorption. It's funny you said you looked at that. I actually did the same thing whenever I heard some of these claims, and I'm going to give a quick shout out to Missouri, kind of along with the lines with this next recommendation. If you read some of Missouri's more recent specifications, they recommend treating additives, specifically the specification, I think it's geared towards rubber, but it can be used for plastic as well. Treating it like a third phase. It's not aggregate. It's not binder. And then putting it into either one of those categories triggers all kinds of problems, but really on the volumetric side. So treating it like a third phase in your volumetric calculations. Bill, this is actually something I've done personally. And then when Punya told me, hey, you should just look at Missouri spec, they actually wrote it in there. I loved it. I think we ought to consider how adding a new phase into asphalt mixes changes mix fundamentals. And so you didn't talk about that here, but you did talk about it this week at NCAT. Right. And so I do appreciate your attention to that detail. With that, I want to open up the floor for questions, and I'll also kind of moderate this. Both Bill and Fan have answered some of the simpler questions in there. But Bill, I'm going to kick a question to you. We had two questions, one by Daniel and one by Andrew. And I'll just summarize them by saying, what do we know about the recyclability of mixes with plastic in it, especially as you start milling them up and grinding them or storing them in a stockpile where the stockpiles are getting rained on? What's the current state of the knowledge? What research gaps are there? And then is there a plan to answer some of those questions?
I can jump on that. There's a couple of different facets you might want to explore there. We get this question a lot with rubber. And if you think about where rubber goes in a dry process in the plant, you're already injecting it in and it's being kind of mixed with asphalt, binder, and then aggregate, and then put into the silo and so forth at mixed production temperatures at the bottom of the drum. So it's going in the first time like that. And there's, we've looked at the health and safety of that occupationally and so forth in the first use of rubber. So when rubber turns into wrap with rubber and it goes into the wrap collar in the same exact place, it's really just kind of a second appearance of the rubber in that part of the drum. And oh, by the way, you can add more asphalt and rubber, at that point in the drum. And so I think we have for decades recycled rubber back into pavements. And so plastic, I think, will be, or at least dry process plastics will be kind of a similar consideration. It's probably pretty easy to go to the field and measure microplastics on roadside. I shouldn't say easy, but there are EPA standards for representative sampling of surfaces, like shoulders and ditches and things like that. And we're doing that on Stadium Boulevard. And we find more other plastic in the environment, and we only find traces of the polyethylene that we put in, almost at the detection limits of the measuring devices. But we find all sorts of other plastics out there, PET and stuff. So you can measure this plastic in the environment, make sure it's at safe levels and it's really staying in the asphalt as it should. And then I guess plant emissions and things like that for occupational safety and environmental, that's another thing. You can use LiDAR and other ways to measure that. And so you could look at that recycling. And then in the stockpiles, I guess you could use the same environmental sampling if you're worried about microplastics leaching out. You can catch them, and you probably are already catching silt and other things. And so I would expect the plastic to be mostly embedded in the wrap, and there might be some plastics kind of sitting out on the edge or in the fines of the wrap. But hopefully that all just stays there at the plant and gets reincorporated in the mix and re-entombed in the asphalt. But certainly something that you should pay attention to. But fortunately, we have EPA standards for measuring that.
Great, thanks. Fan, anything to add to that discussion?
Yeah, the only thing I'll, add, I agree with what, Bill said. We are hopeful that this is not going to be an issue, given our, experience with rubber and how these materials behave in terms of how they were added into the mixture. One thing I would like to share is I'm hopeful that, our industry moving forward will, provide some guidelines on, how to, evaluate or quantify, the recyclability, right? I mean, it's just something that has been talked for a long time, but I don't think that has been standardized in terms of what that really means. So I think moving forward, that can be very beneficial, not only just to plastic, but also for any future additive that, might be people are interested in putting in asphalt. So.
Great. Well, I want to thank the two of you. This has been an excellent webinar. I had lots of engagement, lots of questions. Thank you for answering on the chat. So for the attendees, as you guys know, more information can be found about all of the NCAT's work at the NCAT website here. If you're interested in seeing any of the work that we've done on the test track, all the way back to the original one, you can come and read some of the reports. There's lots of other good stuff on there as well. Travis has a wonderful a training tool, the Training in Your Pocket on YouTube. So you can check that out if you're interested in just learning some basic stuff. It's also really good to kind of introduce terminology and stuff like that to folks who may be new to the industry. If you're interested in more in-depth training courses, we provide that as well. So you can also see that on our website. Go to Education and Training, and you can see what type of training courses we have available. Next month, we will be talking about pavement preservation in urban areas. Again, today's Friday, which is not our normal day, and next month it's going to be the same thing. So June 20th is a Friday. There's a federal holiday on June 19th for Juneteenth, and so to respect everybody's potential being off that day, we don't want you to have to be logging onto a webinar. We will be meeting on Friday as well. After next month, we will go back to our third Thursday of the month. So I do want to thank everyone for your time and your attention. And with that, we will conclude our webinar. Thank you, everybody.